In this last tutorial, I want to go over something called a catalyst, which I introduced a little bit at the beginning of this unit. Now, a catalyst is basically used to increase the rate of reaction. Usually, a lot of the times, reactions are really slow, and you want to be able to speed them up in some way, especially organic reactions. And so, one thing that you could do is add a catalyst to it, where these catalysts will go and react with different substances within the solution that you might have, but they won't be used up, and so they won't end up being in the overall reaction later on. Now, I know I mentioned previously that one way you can determine whether or not you had a catalyst in a reaction is that usually you write them over at the yield arrow within an equation. Another way to look at that, though, if you're dealing with a reaction mechanism, is that you'll see a catalyst appear within one step, usually as a reactant, and then within another step as the product. But it has to happen in that order, where it'll happen as a reactant in one step and then the product of another step. Whereas if you had a reaction intermediate will appear as a product first and then a reactant, within another step. So that's the difference between the two of them. So let's just go through how to figure that out if you were looking at something like this. First of all, it wants you to figure out the overall reaction. So as we went over before, anything on opposite sides of the arrow you can get rid of, anything on the same side of the arrow you can add together. So in this case, if you look through, Cl and Cl happen on opposite sides, you can get rid of those, and then ClO happens on different sides, so you can get rid of those. So you end up in this case with O3 plus O yields. These two O2s happen on the same side of the arrow, so add them together so that you have 2O2. So that takes care of this first half of the problem. And the next, it's asking you if you have any substances that act as catalysts. Again, a catalyst has to show up as a reactant in one step and a product in the next step, in that order. Well, if you go through and look at this, you'll notice that you have Cl happening as a reactant there, Cl happening as a product there. But you're able to cross them off and they don't end up being in the overall reaction. So that would actually be an example of a catalyst. Now, the next question to ask is for a reaction intermediate. Within a reaction intermediate, those are substances that happen as a product first and then a reactant. Well, if you look at this, you'll notice that you have ClO there and ClO there. It happened as a product first, then it occurred as a reactant in the next step. So that will actually be a reaction intermediate. And so, abbreviate it as that. Your reaction intermediate in this case is ClO. Alright, let's try another example of this. Again, it's looking for the overall reaction. It's looking to see if you have any catalysts. It's looking to see if you have any reaction intermediates. So first off, probably is to figure out the overall reaction, which in this case, MnO2 happens there. It happens on the opposite side, so you can cross it out. Mn plus 3 happens there, opposite sides, cross out, and then same thing with our Mn plus 4. Ce plus 4 happens twice on the same side, Ce plus 3 happens twice on the same side, so those you can add together, so that you end up with 2Ce plus 4 plus Tl plus 1 yields 2Ce plus 3 plus Tl plus 3. And that's your overall equation. Now, as far as your catalyst goes, again, you're looking for a substance that happened as a reactant first and then a product. So if you look through this, you'll notice that Mn plus 2 happened as a reactant there and happened as a product there. So that would be an example of a catalyst. Now, if you keep looking, you have an Mn plus 3 that happens as a product first and then a reactant. Same thing with Mn plus 4, product first, then a reactant. So those would both be reaction intermediates. So you can put those down as that.